All right. Good morning, ladies and gentlemen. We'll get started with the presentation. So my name is Steve Thayer. I'm the CTO and co-founder of a consulting firm in the UK called DevOps Group, and we help organizations adopt cloud, agile, and DevOps at scale. We like to say we make the cloud fast, secure, and simple. So this presentation is based on a community, a conference and a meetup that we started in the UK about 5 years ago. And we started the WinOps community 5 years ago because an anonymous Linux administrator told me that you can't do DevOps on Windows. So we founded this community, winops.org, in order to try and prove him wrong, basically. And there was a lot of people who, in large enterprise organizations, who were trying to learn more about DevOps, but all the conferences that you went to were all basically based on Linux. So there wasn't a natural place for people to come and learn about DevOps on Windows. So when that person said you can't do DevOps on Windows, it was really based on, I think, four misunderstandings, and I'm going to walk through these 4 misunderstandings. Grab a seat. Night mode. Oh, everything's yellow. Okay. I don't know why everything is yellow, but give me a second. Mm-hmm. No, it's okay. Mm-hmm. Sorry about that. My laptop still thinks it's considerably later than what it is. Okay. So, it was really based on sort of 4 misunderstandings about, where Windows is and what the Windows ecosystem is. So the first misunderstanding was based upon, what DevOps really is, because DevOps is about a lot more than just technology, and whether it's Windows or whether it's Linux is not the most important question or the most important problem that you have. It's based on a misunderstanding of where the Windows OS and the Windows OS ecosystem is today. Windows isn't what it used to be. It's based on a misunderstanding of the reality of enterprise IT. Windows has a massive estate, and we'll go through this in more detail in enterprise. And it's also based on a misunderstanding of what the vendor landscape is. So I'm just going to start with a very quick recap of what DevOps is and what DevOps means to us. And firstly, why technology is only part of the story. So there's a guy named John Kotter. He's a professor at Harvard, and he wrote an article in 2013 called Accelerate in the Harvard Business Review. And he put this quote was in the article, and it always struck me that, organizations need to change. The market, the ecosystem, the business environment in which we operate has need to change. And the quote, "The hierarchical structures and organizational processes we have used for decades to run and improve our enterprises are no longer up to the task of winning in this faster moving world." And in this article, he goes on to talk about what the answer is. And he uses words like agile and network-centric and multidisciplinary teams. He uses the language of agile software development. He uses the language of DevOps. So you've got one of the world's premier management theorists writing in one of the world's premier management journals about why organizations need to change and why that transformation needs to look a lot like agile software development. So Microsoft define DevOps as the union of people, process, and technology. The Amazon definition, a combination of philosophies, practices, and tools. They're all very, very much very, very similar. And they talk about the need to bring, changes to the way we work, changes to the way we approach work. So in the 7 years that we've been running DevOps Group and consulting with large organizations in financial services, insurance, and retail, we've come up with our own framework for DevOps, which we call Adaptive IT. And Adaptive IT is built on five key pillars. And the first pillar is what we call strategy. It's about working backwards from the customer. Every DevOps case study you'll ever see presented at events like DevOps Enterprise Summit or events like this always starts with a lot of talk about leadership. There was normally a very strong leader in the organization who had the remit to really change the organization. He set clear objectives, or she set clear objectives, and then had clear measurements and metrics about how we were going to achieve that objective. Without that clarity of vision, your DevOps transformation will not succeed. You then have the organizational design. So you have an ecosystem of partners and vendors, people inside and outside the organization that will work together. And then you tend to have product-aligned teams. So long-lived teams that stay together, that have a clear mandate to support and run individual products in your product portfolio. You then hear people talk a lot about a DevOps culture. What does a DevOps culture mean? Google have done a lot of research in this, Project Aristotle. If you Google Project Aristotle, you'll find a lot about their research into psychological safety, how teams learn and work together safely, how autonomy is important to employee satisfaction. So there's lots of great guidance there on how to create a culture that enables people to take risks and to change their organization from within. Fourth pillar is ways of working. So grounded in systems thinking, lean IT. If you've ever read Lean Enterprise by Jez Humble, Joanne Maliski, Barry O'Reilly, and there's another book called Lean Software Development by Tom and Mary Popendiak. So a lot of those ideas that are taken from car manufacturing, so the Toyota production system, about small batch sizes, focusing on the flow of work. There's a book named from Dan Reinertsen called The Principles of Product Development Flow. So there's lots of really good material, and then obviously agile software development. And then the fifth pillar, only 1/5 of the problem, is actually the technology that you run on, the cloud you choose, the platforms that you built, and the automation tools that you use. So, you know, Windows, if you're thinking about, you know, Windows versus Linux, Windows is only in this, you know, this fifth pillar. The rest of it is completely independent of the technology that you use. Generally, when we see people implement DevOps, we see them talk about having multidisciplinary teams. So the idea that you have a team that both builds and runs that software that they develop, so they are responsible for it when it runs in production. When something goes wrong, they get paged, they get called out of bed at 3 a.m. in the morning to resolve the issue. You also see one of the key tenets of DevOps is to have customer feature stories, but also to have what we call operability stories. So some people call them non-functional requirements. The idea is that you care as much about security, resiliency, scalability, deployability, all of those things that make this software easier to manage and run in production. And you know, you have all of your stand-ups, you know, sorry, all of your practices about making sure everything is in source control, you know, triaging unplanned work, you know, making sure that you automate all the things. What this normally turns into in practice, once you have multiple multidisciplinary teams, is you then see the evolution of what we call platform teams. So the idea here is that multiple agile Scrum teams, perhaps supported by site reliability engineering, SRE teams, use these platforms as a service in order to deliver their goods. Like if you've got, like one of the case studies we'll come on to, they have 80 Scrum teams. You're not going to want to have each individual Scrum team running their own Jenkins instance or their own Kubernetes instance, or you know, one team using AWS and one team using Azure and one team using GCP. It makes sense to offer some of these services up as a service. The key distinction here, though, is in order to develop some software and deploy it into production and manage it, they are not sending tickets in to ask for things to be done or ask for work to be built. They are They have all of this stuff available, as shared libraries over here. So, Ansible, Puppet, Chef recipes, whatever it is that you want, Terraform in order to stand up infrastructure. The whole key thing here is this must be delivered as platform as a service, because at any point, if they actually have to send a ticket in and wait on these teams to do something for them, you've just created another centralized bottleneck. And a lot of DevOps is about trying to get away from having these centralized bottlenecks. So, what does this mean for your organization? Well, these statistics are taken from the annual State of DevOps report, which is now published by Google every year. They focus on 4 key metrics, which they believe lead to high-performance IT. So that's deployment frequency, lead time to change. So from code commit to running in production, how long does that take you? They talk about mean time to recover. So how quickly can you recover when something goes wrong? And they talk about change failure rate. So when they compare the low performers with the elite performers, for example, elite performers are 2,604 times faster at fixing something in production than a low performer. For a low performer, when something goes wrong, it's hours or days before they fix it. For an elite performer, it's seconds or minutes before they fix it. But mainly because when they're deploying stuff into production, it's automated. So it's automated to deploy, it's automated to roll it back. Okay? So really, really key. The metric that your bosses will care more about is that those organizations that have this high-performance IT, that have all of this automation, who have adopted DevOps, are twice as likely to achieve their organizational goals. So they will outperform on productivity, they'll outperform on share price, they'll outperform on profit. So there's lots to be said for adopting DevOps for your organization. So let's take a little bit, we'll now segue more deeply into looking in Windows. And let's talk a little bit about Windows Server. So there's kind of four key features that I sort of focus in on when we're looking at the differences between Windows and Linux. Linux has had a command line shell. The Bash shell has existed since Kenninger and Ritchie 1971. Goes way back. But in 2006, Jeffrey Snover introduced PowerShell into Windows. And since then, I think we're now at PowerShell Core v6 was just released, the evolution of PowerShell, the ease at which you can automate Windows Server through PowerShell has just got more and more and more. PowerShell is now open source. PowerShell is now ported to both Linux and Mac OS. So you can use PowerShell wherever you like. I think one of the other areas that Microsoft has lagged behind in comparison to Linux is package management. Linux package management is incredibly mature, with apt-get and yum and RPMs and all that sort of stuff. Microsoft has lagged behind in this very, very badly. But since about 2011, you've had OneGet, which is the sort of Microsoft package manager of package managers, and then underneath that, you've got Chocolatey. Has anybody heard of Chocolatey? Chocolatey? So Chocolatey is just a great package manager for Windows. It's I use it on my personal laptop. Whenever I get a new laptop, I have one Chocolatey command. So I install Chocolatey, and then I have a single Chocolatey command that installs all the applications I need on my laptop. I walk away, I get a coffee for a couple of hours and come back and my laptop's back up. Chocolatey is absolutely awesome. I know the guys that build Chocolatey really well. So, if you are dealing with Windows servers and managing application packages or managing Windows desktops, then Chocolatey is your best friend. Obviously, the hottest thing in Linux world is containers, based on LXC, which has existed in the Linux kernel since 2008. Docker was founded back in 2013. Again, Windows now has containers, Windows Server since 2016, and in Windows 10, and there is now full support for Windows containers and Windows Server nodes in a Kubernetes cluster since 1.14, which came out about 3 months ago. And there will be support for, or there is already support for Windows containers in Kubernetes, in EKS in Amazon, and I think in AKS in Azure as well, since they revved up to 1.14. Again, another distinction between Linux is there are a number of Linux distros, and you can customize your own. You can customize all the way down to the kernel if you want to, and it doesn't have a GUI. Again, Windows Server Core since 2008 has supported running Windows with no GUI at all. If you don't need it, then why would you bother installing it? And it's had customizable server roles to enable you to completely customize the Windows footprint down to the smallest possible thing since 2003. If you're interested in learning more about how the evolution of Windows, there is a great presentation that was presented by Jeffrey Snover, the inventor of PowerShell, that he gave at the conference we started, WinOps. He did in WinOps 2016, called the DevOpsification of Windows Server, where he goes through this, some of the points I've made in a lot more detail. It's slightly dated now because he references Nano Server, and Nano Server has sort of been discontinued as a core OS version, although Nano Server is still available as a Windows container build. But yes, really, really good presentation. Jeffrey's been to WinOps twice. He's a great public speaker. I can't get him to come anymore because he's now at much, much bigger conferences than mine. So the next thing we want to talk about is the reality of enterprise IT. Who here is actually running, Windows Server workloads in production? Everybody? Yeah, most people. So the stats are that at least 50% or more of enterprise IT runs on Windows Server, and that stat is from Gartner. When you look at the workloads that are running in Azure, 50% are on Windows. Interestingly, 50% of them are on Linux. But the reality is there's just a huge install base of Windows in enterprise. Many popular COTS product, commercial off-the-shelf software, only run on Windows Server. Unfortunately, in many cases, some of them are locked to older versions of Windows, which is a real problem for many organizations that are trying to migrate and move into the cloud in particular. But again, massive install base of software. C# is still the 5th most popular language globally, and 45% of professional developers, as measured on the Stack Overflow survey, use Windows as their OS desktop. And then when you look at the stats for C#, it's sort of 5th, 6th, or 7th, depending upon which survey. So there are a lot of people still using C# as their primary language. And whilst C# is now cross-platform, because .NET Core is cross-platform, there are still many features which are only really available if you're using OS as your hosting thing of choice. And last but not least, certainly in the UK, organizations have many people that have the only skill they have is Windows. They don't know Linux at all. There was one large enterprise bank in the UK that sacked 7,200 of their IT staff and then proceeded to hire 6,800 of them back. I think it's fair to say that those people who were sacked and then hired back will probably never trust their employer again. I would say it's a really bad strategy for if you want to have people who believe in your company and your organization. There are not enough IT people in the world, so organizations are finding as part of their DevOps and cloud transformation that they're going to have to invest more and more time and effort and money into their people. So, just saying that I'm going to sort of get rid of my staff because their skills are out of date, you just can't do that. You've got to invest in the skills of the people and bring them up to speed. So, finally, we just talk about DevOps vendor support. Everybody loves Windows these days. Just to pick 4 very common things, Puppet supports Windows and has since 2011. Chef supports Windows, has since 2011. Ansible supports Windows since 2014. Terraform supports Windows and has since 2015. So there's no argument to say, oh, I can't do it, the tools don't support it. Yes, they do. All of the major tools vendors support Windows, and you can pick this open source tool of choice and use it. Obviously, Microsoft now have their own DevOps tooling with the Azure DevOps platform, And obviously, with the acquisition of GitHub, they have even more, choices and things available for, everything from, running and testing your software through to, monitoring it in production through to building out your infrastructure using tools like ARM, the Azure Resource Manager, ARM templates. So in the 5 years we've been running the WinOps conference, annual conference every year, and then monthly meetups every month, we've had some great case studies. So I'm going to walk you through four very, very quick case studies where people have gone through a full DevOps transformation whilst using Windows technology. So the first customer I'm going to talk about is a customer called ASOS, which is probably not really well known over here. ASOS are turnover of just under £2 billion, which would be what, 160 billion rubles or something at 80 to 1. So they are a fashion retailer. They're the fashion destination of choice for 20-somethings, incredibly fast-growing, and a real sort of success story in the e-commerce market in the UK. The challenge that they had was back in 2017, they'd scale up to having 25 Scrum teams, but they'd written their own application lifecycle management framework, ALM framework, all written in custom PowerShell, hundreds of thousands of lines of PowerShell. There was only a few people in the organization that actually understood how this PowerShell worked. So all of these 25 Scrum teams had to come into this one centralized team in order to get anything to deployed into production. So it created a massive bottleneck. And they'd maxed out at about 300 releases a year, which is still not too bad. I mean, that's nearly a release a day. Many organizations would be very happy with a release per day, but they weren't. They wanted to go further. So ASOS was actually a customer of my company. So we worked with them to implement TeamCity for their build server, Octopus Deploy as their deployment tool. And we went out and taught all those little individual teams, here's how to build your own TeamCity jobs. Here's how to build your Octopus deployment jobs. Here's how you can now take control of that build and release cycle to yourself. At the same time, they were going full tilt into an Azure adoption. So we did a lot of work with them about re-architecting their core content management system. And they were slowly decentralizing more and more and giving more and more autonomy to those teams. So if you think about that diagram we had before where we had those distributed teams that had a centralized platform team, that's what we were doing. We were building that platform as a service capability and enabling them to scale out their teams. So as of now, they've got 80 Scrum teams. Remember, this is a fashion retailer that now has 80 full-time development Scrum teams with 7 to 9 people in each team. They're doing 3,800 releases a year, and last year their turnover was £1.8 billion. So they've been able to scale massively because they adopted this DevOps automation, because they adopted this tooling, because they adopted more agile ways of working, because they decentralized stuff out and empowered those individual product teams as much as humanly possible. So really, really great outcome for them. So Ticketmaster, I don't know whether you have Ticketmaster. They're a global ticketing company, so for concerts, events, Ticketmaster run all the ticketing. They do ticketing for things like the Olympics and that sort of, and big sporting events. But they'd grown very, very quite quickly over like the 10 or 15 years, and the biggest problem they had was that they had something like 14 different ticketing applications because they'd acquired different companies around the world, and every time they acquired a company, they got another ticketing platform and another ticketing platform. They had all these data center issues and just everything was too slow. So, what they did was they went to a very product-aligned organization, again, very similar to that diagram. They created a whole bunch of shared platforms, and they went on a very methodical process of containerizing their applications, instrumenting them so that they could see inside the applications in a lot of detail, and then automating as much of this platform as possible. So what it actually looked like was a little bit like this. They had a platform infrastructure team that was helping them build all the infrastructure, including the data center and their cloud migration. They had a platform engineering team, which was all around their monitoring, their CI/CD, continuous delivery tooling, and the actual application runtimes. And then within their organization design, they had groups. Inside each group, they had individual product teams. They had a ops and reliability, also like a site reliability engineering team that was tied to each group. So again, they were devolving as much responsibility as they could out to the individual teams, because the only way you can move faster is push that out to the edge. It's the only way you can accelerate. So, end result for them was they said, really big increase in collaboration across the team. Those shared platforms that they built over here, really reduced the waste, made them more efficient. And there was a significant acceleration in time to market. They were able to launch new features into their application, new Android apps, new iOS apps, new features on their website. Improved their scaling and reliability, because they'd had lots of issues with, when you suddenly have 100,000 people hitting your website because they want to get concert tickets or tickets to big festivals. They spend a lot of money on that sort of resiliency and platform engineering. So a really good result. One of the other companies who came and presented at WinOps was actually Facebook, which was really interesting for us. And so they told a great story. They told a great story about their use of Windows in the production environment. So they run a lot of Windows desktops. At the end of the day, they're a large enterprise. Large enterprises, Microsoft has a 93% share in the desktop market. But what they found was, for both their Windows desktop and their Windows server estate, was that they were using SCCM, System Center Configuration Manager, for managing their estate. And a lot of that knowledge was siloed in one or two individuals. And when they contrasted that with what they were doing on their Linux estate, all their Linux stuff was done using configuration management tools. All of those configurations were checked into source control. The knowledge was shared a lot wider because it was in source control, and there was much better collaboration. So what they wanted to do was, they wanted to manage their Windows estate like they managed their Linux estate. So they built a tool chain, Chocolatey, which with the package manager, PowerShell for gluing stuff together, Chef for their core configuration management, Facility. I can't quite remember what Facility does, but I think again it was related to the configuration management, I think. So they basically ripped out that GUI-based tool, replaced it all with modern tools that they can check everything into source control. What they did was, because they were checking everything into source control, so the Chocolatey configurations, PowerShell, Chef, everything, they started to use the peer review process, so that the pull request process in GitHub, in order to share that knowledge. Before you could check something in, it had to be peer reviewed. By doing that peer review, you were sharing the knowledge out through the team. So it's a really, really nice tip, really, really nice technique, is use the pull request process, the peer review process, to start sharing it. It might be a senior person checking it in, and the person who's doing the peer review might be a junior person, but he's still got to explain what he does, and if the junior person doesn't understand it, then the pull request is not going to be merged in. So it was a really, and the guy said that was one of the real wins for them, was getting this improved visibility and everything in source control, and this improved collaboration. You didn't have to know everything about System Center Configuration Manager to be able to make a change. All you needed to be able to do was edit a text file. You could go in and edit the chef recipe. You could go in there and edit some of that PowerShell. So the last case study we're going to talk about is a company called Call Credit. So Call Credit are a credit checking company like Experian or Equifax. I don't know the Russian equivalents, I'm sorry. But they had a whole stack of issues, very, very manual deployments, very, very siloed organization, lots of handovers, very slow build time. And in the end, the business was not was not very happy, and their customers were not happy. They had, if I remember rightly, they had a single tenant solution. So for every major big customer they had multiple sort of independent versions of the software running, and it took them a very long time to sort of roll changes across. So what they did was that they used some of their Microsoft credits to have a hackathon. So they did a 3-day hackathon event. They got all their developers. They got a lot of support from Microsoft. Microsoft will do this for free with you if you're an enterprise customer. And they did a hackathon to get their core platform into containers on Windows as a proof of concept, using what was then VSTS, now called Azure DevOps. So they not only, so they built an entire tool chain, ending up with their application containerized and then deployed it onto Windows servers, running it as containers. And because they'd had struggled to get investment from the business to do this improvement, they decided to sort of do this as a proof of concept in a hackathon in a really tight 3-day period. And the end result was it worked. They got the application up and running. They could now very easily demonstrate to the business, hey, we've got this in containers. This has this impact on portability, scalability, resilience. And that enabled them to get the business buy-in to actually do this transformation and do it at scale. So sometimes there's a lot to be said for doing something as a proof of concept, and showing very quickly how you can get that return on investment. And then their next step is to actually start refactoring the entire application to pull it apart. So sort of trying to bring this together into some key questions. Also key lessons learned. So across all of the case studies that have been presented at WinOps over the past years, it is very, very clear that technology isn't the constraint to this problem. The real problem is actually the people. Changing the way people work, the way people, like if you've spent, 10, 15 years working at a GUI, and now I'm telling you, we're going to install Windows Core, we're going to take the GUI away, you're going to have to do everything via PowerShell, or you're going to have to do everything by creating, writing stuff in Puppet, and it's all going to be checked into source control. There are a lot of, my background is infrastructure and operations. There are a lot of people, I've been doing this for 30 years, we don't even know what source control is. So we have to start with teaching people Git, basic, well, you have to start with teaching them source control concepts, then you have to teach them a source control system like Git, then you have to teach them PowerShell or Chef or whichever, your Ansible, your tooling thing of choice. And, just getting people to move towards this mindset where I'm going to share all of my knowledge, I'm going to share all of this in a big centralized repository. There are a lot of people who are very much used to hoarding their information. They have their set of scripts in their drive on a server, and I don't want somebody else to have my scripts. And it takes a long time to change people's attitudes towards this stuff, and it's a complicated process. But one of the things that helps to start here, and the next key lesson is about starting with the big picture. For many organizations that we work with who are trying to undergo a DevOps transformation, people in retail, people in insurance, people in financial services, if they don't change, they are literally looking at going out of business. There are many, many new competitors moving into their space. If they don't modernize their applications, they don't modernize their ways of working, then they're actually going to go out of business. And so sometimes you've got to take people to say, hey, take a step back. You have to change what you're doing, otherwise this other bad stuff is going to happen. So it's challenging people to look outside of, I'm a DBA, or I'm an IIS person, or I'm a BizTalk person, or I'm a whatever person. You've got to take a big step back. But the key to success is to start small and iterate. So you want to start with understanding the big picture, But when you come to actually implementing the change, you want to find the smallest pain point, the smallest change that you can possibly start with. And then, because you want the first change to be a success, and then you want the second change to be a bigger success, and the third change to be a bigger success. And you want to snowball that success. So we have a process which we call CPAP. So basically starts with the idea of having a 30-day concept period, get everybody together in a room, paint, plaster the wall with post-it notes and various other things, and try and get everybody on the same page of what are you trying to achieve, what are we here to do, what's the vision. And this is where that leadership stuff that we talked about is so important. You've got to get these leaders in a room and to get them to articulate the vision. Normally you'll then go into a pilot phase, so 30 to 90 days, so 3 months, very aggressively. How do I get a workload into production using a CI/CD pipeline, using all of this automation technology, what we call a minimal viable DevOps pipeline, and really demonstrate that this can be done. It can be done in your business. It can be done in your organization. And then basically now you're into a 6-month cycle of large-scale adoption. And this is just basically how do you apply the pilot idea to the next application, the next environment, the next workload. And depending upon the size of your organization, we were doing some stuff with a large telecom organization. They've sort of said they want to move to the cloud by 2021. We asked them, how many applications do you have? They said about 700. And we said, well, hang on, there's 220 working days in a year. It's 2019 now. They have to be migrating 1.5 applications per day between now and the end of 2021 to be able to actually deliver on that goal. So, a lot of people's ambitions far outweighs their capabilities to actually deliver multiple applications per day being migrated, tested, validated, migrated, tested, validated. The only way to do it is to start with that pilot, get a really solid foundation, and then try and accelerate. And then step 4 is practice. How do you make sure that you have built in all the systems you need so that this is repeatable and reliable? So pretty much last couple of slides left. We're trying to grow the DevOps on Windows community worldwide. And as I said, you can go to winops.org. You can come to the conference in London every year. We have had a conference in San Francisco as well. That was actually run by the guys from Chocolatey. We have monthly meetups. So we've got WinOps in London. It's got about 2,000 members now. There's a WinOps Paris. There's a WinOps in Bristol, which is a small city about an hour away from London. We've got one up in Edinburgh as well that does sort of PowerShell and WinOps. So if you guys go back to where you live, and you know that there are a lot of enterprise organizations that are struggling with DevOps adoption, start a WinOps meetups. Try and get some people together and share. So, we try and get people to share their own blogs, case studies, use the WinOps hashtag as much as possible. Start a local meetup. There are plenty of DevOps meetups. I mean, obviously there's a DevOps conference here. I'm sure there's probably DevOps meetups. In London, you can pretty much go to a DevOps meetup every night of the week. But very little of them have Windows-related content. It's all Linux, it's all Kubernetes. So, go and share there too. If you've got a story about DevOps transformation, about, using Puppet, Ansible, Terraform, all of these great tools, or using DevOps approaches to your work, and predominantly you're working in a Microsoft and Windows environment, go and offer to give that talk, because there are going to be a lot of people that are going to want to come and hear your story. And as I said, start using the WinOps hashtag. If you're interested in learning more about DevOps, every year there is the Global DevOps Bootcamp. So this is an event that happens globally. It's distributed. So basically, at the same time around the globe, people get together to work on a set of DevOps challenges. So it's run like a hackathon over like 6 or 7 hours. You get teams, you get given some challenges, and then you work through all this stuff, normally using Azure DevOps tooling and Azure because it's sponsored by Microsoft. But that's another great way if you want to get hands-on with this technology and really have a play. Obviously, it's been done for this year, so it was in June 2019. So if you look for like June 2020, but you can sign up. And hopefully a venue like this or your meetup group will be able to get together and participate. But it's a great way to have a really structured learning experience. Very similar to that is the Global Azure Bootcamp, which is held every year. Again, this is much more focused on teaching you Azure in particular, but there's also plenty of opportunities there. And obviously, Microsoft have their own cloud developer advocates who are global people who will travel around the world to teach you, everything from Xamarin through to Azure, and a lot of them have some great DevOps skills. There's people in this team who are core committers to Kubernetes, core committers to Docker. So they have a great thing, and I know they're hiring as well. So thank you very much. If there's any questions, we have a lot of resources on our company website, so if you want to scan that QR code, a lot of the diagrams which you've seen are available for download. There's a whole bunch of white papers and other resources. So thank you very much. Does anybody have any questions?
Hello, thank you. How do you think why Microsoft invests so much effort to adopting the technologies on Linux?
So the question is, why do you think Microsoft is spending so much time to port Microsoft technologies to Linux, like SQL Server for Linux, PowerShell for Linux? Is that what you mean?
No, like .NET Core,
Core.
Things like this.
Yeah. The short answer, and I might get shot by Microsoft by saying this, is the future of Microsoft is not in the license money they make from the Windows OS. The future for Microsoft is in the Azure cloud. So they don't need to protect their Windows operating system in the server environment anymore. They just want people to use their technologies. They just want people to move to Azure. So by porting those technologies to Linux, if that makes it more likely that people are going to use it and it makes it more likely that people are going to move to Azure, then that's seen as a good thing. So more and more they're porting this technology, more and more they're open sourcing that technology as well.
Yeah, you are right, but I have, how to think, another opinion.
Yeah.
Do you know what size of base image for Windows Server Core?
Not off the top of my head, no.
1.5 gigabyte. And what size of, for example, Ubuntu or Debian image? 20 megabytes.
20 meg, yeah.
So why I
do one or the other?
Why I will choose Windows for run, for example, Node.js or some cross-platform. Yeah.
I wouldn't.
Applications.
I wouldn't.
Yes.
Which is why 50% of the workloads in Azure are Linux workloads.
It's very inconvenient to use Windows in modern applications. Yeah. For example, in Docker containers for Kubernetes and things like this. So.
Yeah, I mean, I think that's the reality. Is if you're using Node.js, if you're using open source languages and open source technologies, then you're going to run them on Linux. You can't make the business case to run that on Windows. You know, but if you have a significant investment in .NET framework applications that you haven't yet ported to .NET Core, and you are stuck with running in a Windows OS, then Microsoft is trying to make the experience of running Windows a lot better than what it was. I mean, I agree that the image sizes are much larger, but I mean that's kind of why they came out with Nano for as a container OS.
I hope they will improve.
They're trying. They are definitely
a lot of them.
trying.
Thank you.
Any other questions? You can. I was going to say we don't have Slido's not up there, but you can ask questions on Slido as well. Anybody else questions? Nope. Okay. Thank you very much, everybody. Take care.